Hello friends and welcome at my channel. Few more limits with L'Hopital or without. In the last video I just figured out that L'Hopital wasn't needed. Well, I haven't calculated it previously. Let's do it together. So we have a limit x towards 0 of cotangent of x to the power of 1 divided over ln of x. So before we start rewriting it somehow, let us figure out whether we have a trouble at all. So the cotangent is cosine divided by sine. If this is approaching 0, we are dividing by 0. So there is a trouble. 1 divided by ln x is approaching minus infinity if x is tending 0 from the right hand side, by the way. So it's immediately clear this limit is only considered from the right hand side here through the definition, through the domain of ln. And let's see. I have 1 divided by minus, so it's 0. So it's kind of 0 to the power of 0 again. Let us rewrite it again. So x towards 0, we have e to the power of ln of cotangent of x to the power of 1 divided by ln x. Okay, I can get 1 divided by ln x down, and basically it's all about the limit x towards 0. We have ln from the positive side, ln from the cotangent of x divided by ln of x. All right. So ln is not a kind of linear function or whatever, so we cannot just, take ln from the numerator and denominator and put it into one ln. That would be nice, would maybe simplify our computation here somehow, but it's not the case. So once again, what's happening now, considering we are handling both limits, both logarithms? So the cotangent is still running towards plus infinity. Is that correct? Yes. And because we're dividing cosine of 0 by sine of 0, which is almost 0, which is a plus infinity, ln of plus infinity would be a huge number, and we have minus infinity in the denominator. So let's apply L'Hopital now. We have 1 by the cotangent. I've done it a few times, so it's minus 1 divided by the sine squared, right? So this is the definition. This is, well, the derivation also of the limit of cotangent, and we have strictly 1 divided by x in the denominator. Let's simplify it a little bit. So we have a limit x towards 0 from the right-hand side, and we have some fractions involved, so x is coming up. I can take minus in front, all right, well, so let me write it this way. X, and then we have sine squared of x, and the cotangent of x, which is cosine by sine. So I can flip, sine is coming up, cosine is staying in the denominator, and as you can see, we can cancel it. And now things are getting better because, well, I still have a minus. I have a limit x towards 0 from the right hand side still, but we have x divided by the sine of x. Well, this is a familiar limit, and 1 divided by the cosine of x. Okay, so I can separate it by the product rule of the limits. I'll try to put links maybe here to remind you. So this one is going to be 1, and this one is going to be 1 as well, because we're just dividing by 1. So the total result here would be minus 1. All right, so that means we have this total guy is giving us -1, and that would be 1 divided by e. I think it's nice. I'm doing it live. If you see any kind of mistakes, mispronunciation, miscommunication, miswriting, whatever, tell me. It would be glad. I know my channel is not so popular yet, but maybe one day, we'll discuss a bit more about life and mathematics. Okay, let's see one more example. We have a limit x towards 0, 1 divided by x, and then we have a tangent of x. All right, so do we have trouble here? 1 divided by x next to 0, it's almost all the time a trouble. So it's plus or minus infinity, we don't know. Tangent at 0 is 0, so infinity to the power of kind of 0, well, could be nice. All right, so there is no way. We have to rewrite it. Maybe I don't know whether it will help me, but I'm just doing the first step like this. I'm rewriting 1 divided by x as x to the power of -1. And then I'm just applying the power rules. So I'm having x to the power of minus tangent. Uh, is it helping me? Yeah, it's kind of 0 to the power of 0 now, right? I don't know whether it's nicer, better, but let's keep it this way. And now the normal way to solve it here is just e to the power of ln of x to the power of minus tangent of x. And basically it's once again all about the limit x towards 0. We have a minus tangent, so we can kick minus in front, just tangent of x. You see, instead of dividing by x, I'm just putting minus in front, which is nicer for me, times ln x. Let's consider this limit again. So ln is approaching minus infinity, and tangent is approaching 0. So it's kind of minus infinity divided by 0. We cannot handle this with L'Hopital here, but we will rewrite it slightly different. Let's write it this way, minus limit x towards 0. You know what? I'll keep still ln up. I was doing it once in this playlist, and I put ln in the denominator, and it went wrong, so don't want to repeat it. This is 1 divided by the tangent, or just a cotangent, right? This is cosine by sine. All right. What do we have now? Minus infinity still in the numerator, and we're dividing by the tiny small number at sine of 0, which is almost 0, so it's going to be huge. And well, it depends from which side we're approaching. It's clear again here from which side we're approaching because of the domain of ln. Okay, simplifying my life a little bit by recognizing that. And that's for sure plus infinity. So we got minus infinity divided by plus infinity. Let's see what's happening. So we produce derivatives again by the rule of L'Hopital. So it's a minus, a limit, x towards 0 from the positive side. I know that. And we got 1 divided by x divided over minus 1 divided by sine squared of x. So minus minus is gone. We have a limit x towards 0 from the positive side. Sine squared of x is coming in the numerator. X is staying in the denominator. And once again, this is our familiar limit. We can rewrite it as sine of x divided by x times 1 more sine of x. This one would give us 1. And sine of x is giving us just 0 if x is approaching 0. So that means that this total guy is giving us 0, and we are having e to the power of 0, which is 1. think it's enough for today. Thank you for watching and see you in the next video. Bye bye.